So good day, no. In today's video, I will be explaining to you the chapter 7, which is fluid flow in pipes. So once we are talking about pipes, it is mostly related, or the best way to describe it, it is the closed conduits. When you say conduits, this would be the fluids or gases flows may fall or may partially fall, and pipes are referred to as conduits, usually circular, which flow full, and those pipes na partially full is called, are called open channels. So with that, no, fluid flow in pipes may be steady or unsteady. In steady flow, there are two types of flow that exist. They are called laminar and turbulent. The laminar flow, the flow is said to be laminar when the paths of individual fluid particles do not cross or intersect. The flow is always laminar when the Reynolds number is less than 2000, while the turbulent flow, the flow is said to be turbulent when the path of individual particles are irregular and continuously cross each other. Turbulent flow normally occurs when the Reynolds number exceeds 2000. So these two are just mentioned in the earlier chapter, and hoping that you have retained the information that I have said to you. So let's proceed with the critical velocity. Critical velocity in pipes is the velocity below which all turbulence are dumped out by the viscosity of the fluid. This is represented by a Reynolds number of 2000. And once we set Reynolds number, or just simply Re, which is dimensionless, is the ratio of the inertia force to viscous force. So this is the formula for pipes flowing full, which is, as you can see, no, V d rho over mu, or the basic or the most used formula, or ato ang gibasihan, is this one, Vd over mu. So this is mu, and rho. V, mean velocity in meter per second. D, pipe diameter in meter. Mu, kinematic viscosity of the fluid in square meter per second. Mu, absolute or dynamic viscosity, Pascal second. So this one, just remember these formulas. Nang-ani siya because of the nu equals to mu over rho, no, sa to ang chapter 1, if I'm not mistaken, na topic na introduce ni na formula. For non-circular pipes, use D equals to 4R. Then the formula becomes R equals to 4V R rho over mu, or 4VR over nu. So the R here is hydraulic radius, and A is cross-sectional area of pipe, and P is the pipe diameter. Or simply R equals to A over P. Again, the hydraulic radius is equal to A over P. So let's proceed to shearing stress in pipes. Since there is fluid, gas, so of course there is shearing stress. So this is the illustration of how the stress determined. As you can see, shearing stress distribution of the fluid, and this is the dimension or cross-section of the of the pipe, and there is a force 1, force 2 occurring at the sections. Again, section 1 and section 2, and there's also the radius, no, the radius of the pipe, the radius of the considered area sa ato ang force. Again, HGL, EGL, you already know that. So ang pressure over earth, ang pressure head, as well as the velocity head, and the length, considered length. So using the knowledge that we have in static equilibrium equation, which is all forces along horizontal equals to 0 and all going to right is positive, So we concluded na force sub 1, force sub 2 minus force sa stress. Shear, no? So against siya, induyog siya puyog sa force 2. Is equivalent to 0. Fs is now F1 minus F2. And remember that T sub S equals to Fs over area. So tension, this is tau. So the force is also equivalent to pressure and area. So this is Y na P sub 1 and P sub 2. And doing the math here, we arrive, no? Sa area, there is 2 pi x is the radius, L is the length. And the area now, pi x to the power of 2, or pi x squared minus P sub 2. Again, when you say pressure, it is always small letter P. So our tau now is simply this one. P sub 2 minus P sub 1 over 2L times x. Multiply and divide the equation by unit weight. So once we do it, so we arrive this. So this is the most useful one. Wherein the shearing stress, again, this is the shearing stress, tau s equals to unit weight times head loss over 2L. The maximum shearing stress, so maximum, it is tau sub O is at the pipe wall, wherein X equals to R. So ato ang maximum stress equals now to unit weight times head loss over 2L times R, or unit weight, maximum shearing stress equals to, in terms man sa D, so this one. So unit weight head loss times D over 4L. The shear velocity or fraction velocity, so this one is given. So V sub S or Vs equals to the square root of maximum shearing stress over rho, or simply V square root of F over 8. So that you can know more about the topic, so there are examples to be given. The first example is water having kinematic viscosity, which is 1.3 by 10 to the power of negative 6 square meter per second, flows in a 100 millimeter diameter pipe at a flow rate of 0.012 square meter. Flow rate, so it is cubic meter per second. Is the flow laminar or turbulent? So the solution is here. So using the formula, no, RE equals to VZ over nu. So we need to find first the velocity. Since velocity is connected with the discharge, Q over A, so given discharge 0.012 over pi, and it is 100 millimeters, so 0.1 squared over 4. So this one is the area in terms of diameter. So our V or velocity now is 1.527 meter per second. So RE is 1.527 times D 0.1 over nu 1.3 by 10 to the power of negative 6. So our Reynolds number is 117,461.54. It is very far from 2000. So it is greater than, so the flow is, therefore the flow is turbulent. So let's proceed to example number 2. Determine first the shear stress at the walls of a 300 millimeter diameter pipe when the water flowing causes a head loss of 5 meters in 90 meters pipe length. Second, the shear velocity. Third, the shear stress at 500 millimeter from the center line of the pipe. So let's do it. A, shear stress at the walls, no? So using the formula of maximum shearing stress, we're in terms of diameter, so let's use gamma HL or head loss D over 4L is now, since it is related to water, so 9.81 times head loss. The head loss is given, which is 5, and diameter is 300, so it is 0.3 over 4 times the length is given, it is 90. So our maximum shearing stress now is 0.041 kilopascal, or converting to Pascal, it is 4, no? 1 kilo is 1,000, no? 1,000. So cancel ang kilo, therefore the maximum shearing stress is 41 Pascal. So this is the answer for A. Sa B is, let's use shear velocity. So I am compatible with this formula. The first one, so maximum shear stress over rho equals to square root of 41 over 1,000. Once we say rho, so it is the mass density of a certain liquid, or fluid. Since we are considering the water, so 1,000, it is constant at the 4 degrees Celsius. If you have one remembered, no, 0.202 ang answer, meter per second. C is shear stress at the 50 ba to? Okay, it is 50 millimeter, no? So shear stress, tau sub S equals to unit weight HL x over 2L equals now to 9,810 times 5 times 0.05 over 2 times 90. So tau sub S is 13.625 Pascal. So these are the answers. So let's proceed now to fourth topic, head losses in pipe flow. So head losses in pipe flow, or head losses in pipes, may be classified into two: major head loss and minor head loss. So major head loss, which is caused by pipe fraction along straight section of pipe of uniform diameters and uniform roughness, no? Or simply it is H sub F or HF. And minor head loss, which are caused by changes in velocity or direction of flow and commonly expressed in terms of kinetic energy. So let's begin with the major. So ang major na ay mga formulas related, composed of formulas, no? First, Darcy-Weisbach. Second, Manning formula. Third, Hazen-Williams formula. While ang minor head loss is sudden enlargement, sudden contraction, bends, and standard fittings. So let's start with Darcy-Weisbach formula. So this Darcy-Weisbach formula is pipe fraction equation. So it is HF equals to FL over D times V squared over 2G, wherein F is the fraction factor, L is the length of pipe in meter or feet, D is pipe diameter in meter or feet, V is mean or average velocity of flow in meter per second. For non-circular pipes, use D for R. In terms of discharge, so now the formula becomes this one, no, from this to here. So V squared over 2G nahimong 8Q squared over pi squared G D to the power 4, and na-derive ni until this one 8. So this is the value, kaning 0.826. So I am encouraging you to memorize this formula because it is very useful soon sa board exam. The value of F, since na may F, again F is fraction factor. So in terms of laminar flow, it is 64 over Reynolds number. In terms of turbulent flow, first, nahati po siya sa tulo, no? Ang first one is smooth and rough pipes. So it's either 8 maximum shearing stress over rho V squared or 8 V sub S squared over V squared, where Vs is the shear velocity or friction velocity. And second, smooth pipes wherein the Reynolds number between 3,000 and 100,000. So our F now is 0.316 over Reynolds number to the power of 0.25. And lastly, for smooth pipes, the Reynolds number up to about 3 million. So it is 1 over square root of F equals to 2 log Reynolds number square root of F minus 0.8 or 0.80. So this is the example, no? Fluid flows through a 200 millimeter diameter pipe, 150 meters long at a Reynolds number of 1,750, and we are asked to calculate the discharge if the head loss is 175 meter. So the solution is here. So considering that given ang Reynolds number, it is 1,750, and accordingly, it is less than 2,000, so it is laminar flow. So once laminar flow, we use the formula F equals to 64 over V, or Reynolds number. So 64 over 1750 or 1,750, it is now 0.0366, and we are asked the discharge. So using the Darcy-Weisbach formula, HF equals to 0.0826 FLQ squared to the Q to the power of 2 over D to the power of 5. So 0.0826 times 0.0366 given, no? Solved by us, and L is 150, and discharge is unknown. Head loss or major head loss is given 175 over D. Diameter is also given 0.2 to the power of 5. So using your calculator, or let's do the manual, no? Cross multiply Q square root of ato nang ikuan square root both sides so that mawala ang squared sa Q. So 175 times, I think I am wrong with 200. It is 20. Oh, okay, it is 20. It is 20, so 0.02 to the power of 5 over 0.0826 times 0.0366 times 150. Q now is 0.0011 cubic meter per second, or Q now is 1.1 liter per second. So this is the answer for first example. No? This one. Second example is, what commercial size of new cast iron pipe shall be used to carry 4,490 GPM grams per meter, if I'm not mistaken, on GPM, with a loss of head of 10.56 feet per mile, and we are instructed to assume that F, or fraction coefficient or fraction factor is 0.090. So let's do this solution. HF equals to FL over D times V squared over 2G. No? The first formula sa Darcy. And take note that to be able to get the F, so let's identify first the Reynolds number. So Reynolds is 1.5 and it is less than 2,000, so it is laminar. So once laminar, let's use the formula, no, laminar flow sa F. So F equals to 64 over R, or 64 over 1.5, and now it is 0.0427. So natay value for F, natay value C, natay value for L, and D is the rin na to ko ng size V squared over 2G. Okay, we're good with that. So F is 0.0427 times 750. No, 750 plus in, I think, oh my god, mali ako ang solution. This is not the right solution, sorry. So, the real solution, no, it should be, ipangutan mo yung commercial size, and the solution that I have shown to you is for your VS. But anyway, so mag-resolve ta. HF equals to 0.0826 FLQ to the power of 2, or Q squared over D to the power of 5. Take note na we are fluid man, so never use the gram, so it is gallon. No? So let me check, or let me correct my statement beforehand. So 490 gallon per meter, or I mean per minute. So convert to muna to siya into cubic meter per second. So sa isa ka galon na ay 3.79 liter. No, if I'm not mistaken. And as also sa isa ka cubic meter na ay 1,000 ka litro. As well as sa 1 meter there is 60 seconds. I mean 1 minute. So therefore, atong Q now is mulo siya gani 4,490 times 379 over 1,000 times 60, or 0.284 cubic meter per second. So our head loss is, or should be converted man, so 10.56, no, feet. So 1 meter na ay 3.28 ka feet. So 3.22 meters ato ang head loss. As well ato ang length per mile. So nakasapot siya ni 1 mile. sa 1 mile na ay 5,280 ka-feet, as well as again 3.28 feet per meter. So ato nang pang-cancel, so atong length now is 1,609.76 meters. So we are near sa tuang sa tuang solution. So using the formula kani 3.22 equals to 0.0826 times F is pila man, no, instructed man ta na 0.019 times L is 1,609.76 times Q is 0.284 to the power of 2 or squared. Ang D, kanina itong paano, D to the power 5. So doing the math here, mahimo siyang D equals to 0.576 meter, or convert to millimeters, so 1 meter 1,000 millimeter. Therefore it will be 576 millimeter. So this is the answer. Now i-cross multiply na to, tapos erase na to to the power of 1 over 5. So makansel na to ang power sa D. So that's how we solve sa diameter or sa commercial size of the new cast iron. So we're good with the Darcy-Weisbach formula. So let's proceed to Manning formula. When you say Manning formula, it is one of the best known open channel formula and is commonly used in pipes. So the formula is kani V equals to 1 over N times R to the power of 2/3 times S to the power of 1/2. SI version. Sa English unit, it is 1.486 over N R to the power of 2/3 S to the power of 1/2. So take note na ang N is roughness coefficient, R is hydraulic reduced, S is the slope of the energy grade line, HF over L. So forming the head loss formula here using this Manning formula, so thinking that S is HF over L and R equals to D over 4. So from this, no, sa SI version of the unit, so atong ibuta ang D over 4 sa R as well HF sa S, HF over L sa S. So we come up na ngani HF over L to the power of 1/2 ato siyang squared as well as ang pika side 2.5198 NV kani siya gikan ni siya sa 4 to the power of 2/3, no? Tapos over D to the power of 2/3. So squared both sides, so HF over L equals to 6.35 N squared V squared over 4 to the power D to the power 4 over 3. Therefore our HF or head loss now is 6.35 N squared L V squared over D to the power 4/3. So in terms of velocity, for non-circular, if I have not, no, this one. For non-circular pipes, use the 4R in terms of discharge. So with the formula, no, 6.35 N squared L, wherein atong gamiton tong V equals to Q over A. Q now with the area of pi d squared over 4 all over d to the power 4 over 3. So doing the math here, ato siyang kwanon. So it turns out na squared maning. So 4 to the power of 4 squared is 16. So 6.35 n squared L times 16 q squared over pi squared d to the power of 4 all over d to the power 4 over 3. So ipang-ubos na to ning denominator sa overall denominator. So it will become 6.35 n squared L times 16 q squared all over pi squared d to the power 16 over 3. So our head loss now is 10.29 n squared L q squared over d to the power of 16 over 3. Again, in terms of discharge, and the first one is in terms of velocity. So let's use the formulas in our examples. So the first one is oil with a specific gravity of 0.95 flows at 200 liter per second through a 500 meter of 200 millimeter diameter pipe. We are asked to determine the head loss using the roughness coefficient 0.012. So solution. So flows man, hatag siya discharge. So let's use in terms of discharge na head loss. 10.29 n squared L q squared over d to the power 16 over 3. So q is 200 liter per second, or diretso na nato 0.20 cubic meter per second. So our head loss is 10.29, n is 0.012, L is 500, and Q is 0.2, all over D is 0.2 to the power of 16 over 3, and head loss now is 158.36 meters. So the second example is too long, no? Solution. So anyway, find the approximate flow rate at which water will flow in a conduit shape in the form of an equilateral triangle if the head loss is 5 meter per 1 meter length. The cross-section area of the duct is 0.075 square meter, and we are instructed to use the roughness coefficient of 0.011. So the solution is Q equals to AV, right? And head loss, since as you can observe, naghatag siya og velocity, or simply we can use the discharge, not with this formula katong second one. We will be solving the discharge using the katong major na formula, Q equals to AV. So atong gamitan na in terms of velocity na head loss na Manning formula. So therefore it would be 6.35 n squared L V squared over d to the power of 4/3. So 5 ang head loss, 6.35. Ang roughness coefficient is 0.75. Squared L is 1,000. Why 1,000? Because okay, this is not 1 meter, but it is km or kilometer, no, this one. So 1 kilometer is equivalent to 1,000 meter, and V squared is unknown, as well ang D Unknown po ang D. So for non-circular, conduit, wherein D equals to 4R, right? So let's draw an illustration. When you say equilateral triangle, so all sides are equal. So let's assume na this is perfect triangle, no? I mean equilateral triangle having 60 degrees. So once you say equilateral, so it is 60 ang angle, both corner or vertex. Same ang side, same ang angle. So ang area ani is 1/2 a squared sine theta or 60. So ang area, I think it is given ba, the cross-sectional area of the dock is 0.075. So 0.075 equals to 1/2 a squared sine 60 degrees. So a equals now to square root of 2 times 0.075 all over sine 60 degrees. Our A now is 0.416 meters, or I mean of a meter, or sine 60 is equivalent to, di ba, opposite of hypotenuse. So opposite ang H, hypotenuse ang A. So H now is A sine 60. Right? Another solving of area A niya. So di ba area is 1/2 BH. So 1/2 B side is A and H is A sine 60 degrees. So A now is 1/2 A squared sine 60. So 0.075 equals to 1/2 A squared sine 60 degrees. So our A is 0.416 meter of a meter. So the perimeter of this is A plus A plus A, or 3A, or 3 times 0.416. So our P is 1.248. So dali na to ang R, we're in A over P. So resolve na to anay, given ang area, ang perimeter is not. So we solve it using the A of the equilateral triangle. So 0.075 over the perimeter is 1.248. R now is 0.06 meter. So our D is 4R man. So 4 times 0.06 equals to 0.24 meter. So balik na sa napending na solution, which is this one, no? This one. So 5 equals to 6.35 times 0.011 squared times 1000 v squared over 0.24 to the power of 4 over 3, or cross multiplication, and v equals to square root of 5 times 0.24 to the power of 4 over 3, 6.35 times 0.011 squared times 1000. So our V is 0.985 meter per second. So our Q equals to AV is 0.075 times 0.985 or our discharge now is 0.074 cubic meter per second. So this is the answer. So let's proceed to Hazen-Williams formula. So Hazen-Williams formula is widely used in waterworks, no? Industry. This formula is applicable only to the flow of water in pipes larger than 50 or 2 inches and velocity less than 3 meters per second. This formula was designed for flow in both pipes and open channels, but it is more commonly used in pipes. So sa English unit, it is V equals to 1.318 C sub 1 R to the power of 0.63 times S to the power of 0.54. For circular pipes flowing full, the formula becomes Q equals to 0.4322 C sub 1 D to the power of 2.63 S to the power of 0.54. In SI version or SI unit, it is V equals to 0.849 C sub 1 R to the power of 0.63 times S to the power of 0.54. For circular pipes flowing full, this formula becomes Q equals to 0.2785 C sub 1 D to the power of 2.63 times S to the power of 0.54, or simply the formula of the head loss now is this one: 10 to the power 10.67 LQ to the power of 1.85 over C sub 1 to the power of 1.85 times D to the power of 4.87. So I am encouraging you to memorize this formula. C sub 1, don't forget that it is Hazen-Williams coefficient. Now C sub 1. So for example, fluid flows through 75 millimeter diameter pipe, 150 meter long, with a mean velocity of 2.5 meter per second. And we are asked to determine the head loss using Hazen-Williams coefficient, now 110. So using the formula, HF equals to 10.67 LQ to the power of 1.85 all over C to the power of 1.85 times D to the power of 4.87. So 10.67 L is 150. No, 150. And Q to the power of 55. Ito pang pangitaw ng Q. Over C sub 1 is 110 to the power of 1.85. And D is 75 months. So it would be 0.075 to the power of 4.87. So pending pa. Our Q now is AV, diba? Equals to AV. So therefore it would be given ba ang area is to be solved pa by 0.075 squared over 4 times ang V is 2.5, no? Tapos Q now is 0.011 cubic meter per second. Thus our HF is 10.67 times 150 times 0.011 to the power of 1.85 all over 110 to the power of 1.85 times 0.075 to the power of 4.87. So our HF is 19.174 meters. So this is the answer. So second example, solve using the N. N is sa panong Manning formula, roughness coefficient. So it would be HF equals to 10.29 n squared L q squared over d to the power of 16 over 3. Right? Or we can use D. Pero i-prefer lang na ng Q. So therefore, 10.29 N is 0.014 times L is 150, Q is 0.011 squared over D is 0.075 to the power 16 over 3. So our HF is 56.578 meters. So in terms naman sa velocity, HF equals to 6.35 n squared LV squared all over d to the power 4 over 3, or 6.35 times 0.014 squared times 150 ang L. Ang V is sa first example, our given is 2.5 squared over d 0.075 to the power 4 over 3. So our head loss is 36.89 meters. So it is very near sa, greater lang siya sa in terms of discharge, pero same answer. So let's proceed now to minor head loss. So sa first, it is the sudden enlargement, no? Pero let's know more about or let's deeply know more about sa minor head loss. Minor head losses are caused by changes in direction or velocity of flow. These changes may be due to sudden contraction, sudden enlargement, valves, bends, or any other pipe fittings. These losses can usually be neglected if the length of the pipeline is greater than 1,500 times the pipe's diameter. However, in short pipelines, because these losses may be exceeding the fraction losses, the minor losses must be considered. So that's why, no? So sudden enlargement. So as you can see, na section 1, section 2 sa local pipes with different diameters. So the head loss HE, head loss po na siya, across a sudden enlargement of pipe, diameter is this one, the formula, wherein head loss equals to V sub 1 minus V sub 2 squared over 2G, and it is in meter. So V sub 1 is velocity before enlargement, V sub 2 is velocity after enlargement. Another equation for the head loss caused by sudden enlargement was determined experimentally by Archer. So it is from Archer, no? And given as V sub 1 minus V sub 2 to the power of 1.92 over 2G. So ning kwan lang og gikan sa 2 na imong 1.92. So example ta, determine the head loss or the loss of head due to the sudden enlargement in a pipe carrying 57 liters per second of water, which suddenly changes from a diameter of 15 meters to 15 cm to 20 cm. Also find the pressure difference between points before and after the change of section. Solution. So let's draw, no, and so diameter, this is the 15 cm na diameter, sudden enlargement, it becomes 20 cm diameter. So 1 and 2. So HE equals to V sub 1 minus V sub 2 squared over 2G. And first, let's solve the V sub 1. which is from Q equals to AV. So Q over A now, it would be 0.057 over pi times 0.015 squared over 4, 0.15 because it is cm. So V sub 1 is 3.23 meter per second, and V sub 2 is kinetic area 1 Q over area 2, 0.057 over pi times 0.20 squared over 4. So V sub 2 is 1.81 meter per second. So this is the solution. So continuation of the solution, HE equals now to 3.23 minus 1.81 squared over 2 times 9.81. So it is 0.103. So to be able to solve the head loss due to sudden enlargement mo naman ni. And now ang gikuha na to, okay na to, no, for the first asked question. But remember that we are asked about the pressure difference, so we can use the Bernoulli's energy equation. So BE, we're in V sub 1 squared over 2G plus pressure head P sub 1 over gamma plus elevation head Z sub 1 equals to V sub 2 squared over 2G plus P sub 2 over gamma plus C sub 2 plus HE. So head loss, no? So atong input ang mga values na we have arrived. So 3.23 squared over 2 times 9.81 plus P sub 1 over gamma plus 0 because atong datum is at inside man sa pipe equals to 1.81 squared over 2 times 9.81 plus P sub 2 over gamma plus 0 gihapon nato ang C sub 2. HE is 0.103. So P sub 1 gamma minus P sub 2 gamma equals now to 1.81 squared over 2 times 9.81 plus 0.103 minus 3.23 squared over 2 times 9.81. So P sub 1 gamma minus P sub 2 gamma is now equivalent to minus 0.262 and P sub 1 minus P sub 2 negative 0.262 times 9.81, and remember it is water, no? So negative 2.568 kilopascal. So this is the answer. So let's proceed now to second topic for minor head loss, sudden contraction. As you can see, katuuna is enlarged. Now, gikan sa dako na pipe diameter into small, so contract. The head loss, HC, across a sudden contraction of a pipe is H sub C equals to KC, V squared over 2G. Kc is the coefficient of sudden contraction. So based from here, the table, no? And V is the velocity of smaller pipe. As you can see, ang table na D over 2 or D sub 2 over D sub 1. Muna yung mga kabalan. And ang Kc or coefficient of sudden contraction, na po siya mga certain kabalan. And it is found on our book. So just search it or have a read on it, no? Special case of sudden contraction is entrance loss of pipes connected to a sieve wire. For this case, the values of Kc are as follows. So this one. So plus connection, there would be 0.5, projecting connection 1, rounded connection 0.05, slightly rounded entrance is 0.25, sharp cornered entrance is 0.5. So, banata, example. So what is the loss of head due to sudden contraction in a pipe carrying 57 liters per second of water which suddenly changes from 20 cm to 15 cm? Also find the pressure difference resulting from the change of section. So as you can observe, it is same with the first examples, the sudden enlargement, but with a twist, which is 20 cm ang una, and the next pipe is, or the conjoined pipe is 15 cm. So dako ang una nato na pipe. Same po yung question as you can see. So 20 cm diameter, 15 cm diameter. First section, second section. Well, what is the changes of this, no, of this on solving of the problem? So involved na nato ang D sub 2 over D sub 1, which is 15, 0.15 and 0.20, and the result is 0.75. As 0.75, so as you can see sa ato ang table, walay 0.75. It's only that 0.75, 0.7, 0.8. So diranto nga. So the only thing is mugamit ta og values, no? Mugamit tag average values of the Kc. So 0.70 sa table, it is 0.22. In terms of Kc, ha, 0.22. So 0.8 sa Kc, it is 0.15. Right? So kung ano tong average ani, i-add ni siya. So it would be 37. So mahimo ang Kc nato, divide 2, no, add this 2 and divide 2, so 0.85, 185. So V equals to Q over A, or 0.057 over pi, 0.15 squared over 4. So our V, again, ang V nato sa sudden contraction is, so the value of our velocity is, it would be 3.23 meter per second. So our head loss now is Kc V squared over 2G. It is 0.185. Yup, diba? As I have introduced to you the Kc, 3.23 squared over 2 times 9.81. So our HC now is 0.098 meters of a meter. So using the BEE, V1 squared over 2G plus P sub 1 gamma plus C sub 1 equals to V sub 2 squared over 2G plus V sub 2 over gamma plus Z sub 2 plus H sub C, or head loss in terms of contraction. Take note that only V sub 2 is granted sa tuang 3.23 meter per second, and V sub 1 is still unknown. So using equation, discharge 0.57 over pi times 0.20 squared over 4, so it is 1.81 meter per second. So now 1.81 squared over 2 times 9.81 plus P sub 1 gamma plus 0 equals to 3.23 squared over 2 times 9.81 plus P sub 2 over gamma plus 0 plus HC is 0.098. So this one is 0.167, the other one is 0.532. So P sub 1 over gamma minus P sub 2 over gamma equals now to 0.532 plus 0.098 minus 0.167. So P sub 1 minus P sub 2 equals now to 0, this all, no? 4.463 times 9.81, or P sub 1 minus P sub 2 equals to 4.542 kilopascal. So this is the answer for example under the sudden contraction. So let's proceed sa third one, no, sa minor head loss, bends and standard fittings. The head loss HB that occurs in pipe fittings such as valves and elbows and vents is given by HB, or H sub B equals to K V squared over 2G. So these are the examples, no. It's either it's 90 or 45 or 180 nakabend siya. So more for that, these are the factors of pipe fittings. Sa fitting, sa globe valve fully open, the K is 10, L over D is 350, and just read it on our book, no? So let's proceed sa tuang example. So determine the loss of head due to pipe fittings of a 250 mm diameter. Solution. It would be naka-indicate man ang 250. Okay. 250 diameter pipe, walang akong question, carrying 65 liter per second of H2O. Connected to a 45 degrees elbow, no? So atong kuanon dari, this one is 45. So this is the bend, no? So 250 millimeter diameter to 50 millimeter diameter. So 45 degrees elbow, velocity. So HB equals to K V squared over 2G. So our K here is based sa atong na-draw is that 45 elbow here, no? This one. So L over D is 15. So 0.42. And ang atong velocity is Q over A. So on this charge, it is given, no? It would be 0.065 over pi times 0.25 squared over 4. So our V is 1.324 meter per second. So atong HB is 0.42 times 1.324 squared over 2 times 9.81. So our HB is 0.0375 of a meter. So this is the answer. So this is the part 1 of our discussion for chapter 7, and hope that you have extracted knowledge from what I have discussed with you. So goodbye and thank you for watching.